And then you should have done 1 through 8 last night. Okay, hopefully you did, because I'm just letting you know, if you didn't, it's going to be overwhelming, okay, when you start doing problems and you're not asking questions, all right? Then tonight you need to finish up to 12, okay? And then tomorrow, really I'm just going to answer like brief questions, because you should have pretty much done all of it. Does that make sense? 13 to 16, okay, are not going to be brand new problems, okay? So you should feel pretty comfortable when you do 13 to 16. Guys, if you are not doing homework, do it tonight, because it's going to be overwhelming by the time we start to review this, okay? All right, just for a quick review, because you guys know formulas, I want you to pull out your formula sheet. On the front of your sheet, we have the definition of a derivative. I think it's like the third formula on your formula sheet or something like that. Okay, and I'll call this sometimes I'll call it your yellow sheet, sometimes I'll call it your formula sheet. All right, and let's write the formula for a derivative. Okay, before we knew power rule, the only way we knew how to do a derivative, okay, was this formula. And remember, we talked about limits at first, because all of calculus basically is a limit. The definition of a derivative is a limit as h goes to 0 of f of x plus h minus f of x all over h, okay? That's a formula you should memorize, okay? But it's also going to be on your formula sheet, okay? And another formula that you have an alternative form for the derivative, okay? And that is f prime at c. The alternative form is actually at a point. So this c is actually some value, like 3 or 2 or 5, some x value. That's also a derivative. I'm sorry, it's also a limit. So that's a limit as x goes to c of f of x minus f of c over x minus c, okay? And those are the formulas that derivatives were derived from. I mean, you started with these formulas, and then someone figured out, hey, there's this thing called the power rule. You don't actually have to do all this. You could just do the power rule. And someone else said, hey, I'm smarter than you. I figured out the product rule, okay, and the quotient rule. And so they figured out you actually don't have to use these formulas all the time. But this is how it started. This is how Newton started, right? He figured out this formula. Okay, and so how do we put this into the formula? Okay, so let's say we didn't know the power rule, or we didn't know our derivative trig functions over there. Okay, the way they did in the old days, okay, when they figured out what the derivative of tangent x was, okay, they just stuck it into this formula. Okay, if you know that f of x is equal to tangent x, then you ask yourself, okay, what's f of x plus h then? What's this term going to be? Well, this just says everywhere there's an x, I'm going to put what? X plus h. Everywhere there's an x, replace it with x plus h. So here's an x here. I'm replacing that with x plus h. Here's an x here. I'm going to replace that with x plus h. Okay. So for the function tangent x, f of x plus h is equal to tangent x plus h. So I'm going to put that right here where this first term is. So this is going to be the tangent of x plus h minus what? Minus f of x. Well, what is f of x in this picture? F of x is equal to tangent x. So you would just put tangent x all over h, okay? And this is the expression you use to find the derivative. So if they said, hey, write the derivative of f in terms of the limit, okay? Then what you would do is you would write this blue part here, you know, minus this part right here. Okay, and then if you knew how to do limits, you would figure this out, and guess what this would be equal to? Secant squared x. You would figure out the derivative of tangent is actually secant squared x, actually you know, multiplying out and actually using some trig properties that you probably forgot from pre-cal. Okay, huh? Well, this formula is right here. This black formula is okay, but on your test, does that make sense? You might have this. Oh, and these are on your notes. Yeah, these are your notes. Okay. All right. And then the next question, what if I didn't have tangent of x? What if they say, hey, what's the derivative of f of x written out in limit form? Okay, written out in limit form. Well, once again, you'd write f prime of x is equal to the limit as h goes to 0 of what? Of f of x plus h. Well, what is f of x plus h? Well, it's just everywhere that there's an x, what are you going to put instead? X plus h. So this f of x plus h, okay, is going to be negative 3 Everywhere there's an x, I'm going to put x plus h, okay, squared plus 2. Everywhere there's an x, I'm going to put x plus h. And that's what f of x plus h is for this problem. So guys, I'm continuing on your notes from yesterday. And so what is the limit of this? Okay, what is the derivative? It said limit as h goes to 0 of, okay, this term right here of f of x plus h. For this function f of x plus h is equal to negative 3 x plus h quantity squared plus 2 x plus h, okay? This green right here I'm writing is equivalent to this green right here I'm circling. That's the f of x plus h. And then I just copy down the minus sign. Minus what? Well, the formula says minus f of x. So what is f of x in this formula? F of x is negative 3x squared plus 2x. Okay, and then you just say all over h. Okay, and what did I just do? If I didn't know the power rule, this is how you get the derivative. Okay, you get the derivative by taking the limit as h goes to 0 of f of x plus h minus f of x all over h. And guess what this is equal to? Can someone tell me what this is equal to? Negative 6x plus 2. Okay, so magic. If you actually know the power rule, you can do this. There's a lot going on over there. There's a lot. Okay, if you don't know the power rule, then you're just gonna, then you'd have to actually take the limit of all this and multiply and simplify it out. But if you know the power rule, you know the answer. Okay, all right. So I'm thinking about putting that on your final. Okay, so just FYI, trying to review you guys a little bit at a time. We're going to do this problem here. This is a luggage problem, okay? And you've got a shipping carton, and they're telling you what a girth is. Apparently, that's maybe a common term if you work for FedEx. I don't know, but they're telling you you've got kind of like this golf bag here, okay? It's got a square end, okay, and it's kind of long and rectangular, like this, okay? And since it says here, the sum of the girth and the length of the package cannot be more than 100, okay? That's some sort of constraint that you have. Find the dimensions of the package with the square end. So they're saying this package end is kind of like a duffel bag, but they've made this into a square. And if this is a square, then if one side is X, guess what all the other sides are? Okay, and you don't know the length of this, so I'm just going to say the length is y. You can call it any letter you want, but you don't know the length, but you do know all of these are going to be the same length. Okay, what you want to do is you want to find the dimensions of the package with the square end that has the largest volume. So my objective function is I'm going to maximize the volume. Okay, so I need a formula for volume though. So looking at my picture, what's my formula for volume? You guys, okay, it's the area of the base times the height. Okay, so I'm getting x squared times y, x times y. All right, that's going to be my objective function. So that means if I'm maximizing or minimizing it, I'm going to take the derivative and set that equal to 0. On the side where, okay, if I take the derivative, I can choose what to take the derivative of. I can do d dt, which is kind of silly. This is not a related rates problem, but there's no t over there. I could do d dx. I could do ddy, okay? But do you see, I'm going to be stuck with implicit differentiation. So to avoid that, I'm going to come back to my problem and say, is there an equation that relates x and y that I can use to replace in here? Okay, so what equation would replace x and y? So let's erase that. What equation would replace x and y? Well, let's see. I have the sum, I have the sum of the girth, okay? And they've told me what a girth is, okay? The girth is a perimeter of the end. So it's actually, the girth is x plus x plus x plus x. So it's 4x. So they're saying the sum of the girth and the length of the package. So they're saying the sum of 4x plus y is actually greater than or equal to 100. Okay, and I'm going to maximize this volume. So, oh yeah, you're right. Yes, less than or equal to 100. Thank you. Okay, so I'm going to maximize this volume so that whatever x is or y is, I'm going to get it as big as possible. Does that make sense? As big as possible. So in a sense, I can leave this as less than or equal to, but really, if I'm trying to get x and y as big as possible, I want it to be equal to 100. Does that make sense? I want to maximize as much as I can. So I'm just going to change this to x plus y is equal to 100. Okay, it's going to give me the same answer. All right. So I've got an equation with x and y. I've got x and y over here. I'm going to solve for one or the other. You guys okay if I solve for y? Okay, so I get 100 minus 4x. So what I do is I move that over here. Okay, so that now I have only x's. And why did I do that? So that when I take the derivative, it's a lot easier. I don't have to use implicit differentiation. Okay, are you guys ready to take the derivative, or is there anything you'd like to do before? Yeah, let's go ahead and distribute this, okay? You don't have to, but it actually helps you to take the derivative a little bit, with a little bit less work. All right, I think I did that right. Okay, so I'm trying to maximize the volume. I got an equation for volume with only x's. Okay, now I'm going to take the derivative. Wait, have I taken the derivative yet? Not yet. So let's go ahead and take the derivative of both sides. The derivative of v is v prime. The derivative of 100x squared is 200x minus 12x squared. I took the derivative. Now what do I set the derivative equal to? 0. Go ahead and solve for your x, and that's your critical point. And that's where your maximum or minimum is going to happen. The easiest way to do this, I think, is actually to pull out, I think this is divisible by 4 and x. So pull out 4 and x, and what you'll get is 50, no, just 50, not 50x, just 50 minus 3x. If I did that right, I'm trying to check to make sure I did that right. Okay, so this is equal to 0. So the reason you factor is because if you can get something times something is equal to 0, guess what one of these somethings is? 0. So that means either 4x is equal to 0, that means x is equal to 0, or 50 minus 3x is equal to 0, which means 3x is equal to 50 and x is equal to 50 over 3. Okay? Now I want you guys to think about this. Remember what I told you. When we're maximizing and minimizing, when you get the critical point, it could be a maximum or it could be a minimum. Remember I said United Airlines wants to, they need to go check to see if they actually maximize profit, if they didn't minimize profit, okay? Because when you get an answer, it could be the answer that gives you a minimum, or it could be the answer that gives you a maximum. Guys, what happens if we use x equals 0? Go look at my picture here. What would happen if x is equal to 0? You wouldn't even have a box. Wouldn't that be the minimum volume? Right? If I want to minimize the volume, if I don't have a box, that really is a minimum. I wouldn't go on vacation, right? Okay, so this gave me the minimum, and that's really not what I was looking for. But it certainly makes sense that x equals 0 became an answer. Okay, so let me use the x equals 50 over 3. If x is equal to 50 over 3, I can actually figure out what my y is equal to. This would be 100 minus 200 over 3. Okay, I'm going to get a common denominator so that I can just get one number for this. So I'm going to change this to 300 over 3 minus 200 over 3. So I get 100 over 3 for my y. So there's my y, and there's my x. You guys good? Okay, now let's make sure we answered the question. Okay, so I'm going to go back up. Okay, and the question is, find the dimensions of the package with the largest volume. Okay, so guys, make sure you understand, this package is a 3D package, so there are actually 3 dimensions. I know I found x and y, but this is really x by y, okay? So your dimensions are going to be 50 over 3 by 50 over 3 by 100 over 3. Does that make sense to you? If they had blanks for the dimensions, there'll be 3 blanks, and you need to know every single blank. And I think these are inches, so if they ask for units, it'd be inches by inches by inches. Okay? Any questions on the girth problem? I think you have a couple of those on your homework. There's another problem which I think is kind of a little bit more challenging, and it's the cylinder problem. And this is kind of interesting because if you're super interested in this, you can think about when green beans, when Del Monte designs their green bean can, like why do they pick the size that they pick? What are they trying to minimize or maximize? Also, when soda cans, like why do they, you know, why did they pick the size that they picked? Was there an optimal size that they could have picked? So this is kind of an interesting thing to think about. Okay, so what I have here is basically a soda can made of metal. It's got a volume of 355, and it's going to be constructed with the least amount of metal. They give me the volume of the cylinder and a surface area of a cylinder. I just want to let you know, I'm not as nice as this worksheet is. Okay, so on your test, you're not going to get the volume and surface area formulas, okay? But let me just talk to you guys about what these formulas are, and hopefully you can develop them yourself, okay? If I wanted the volume of this can, isn't the volume of this can just the base times the height, right? And so isn't the base of this just a circle? So this is just be pi r squared times h. I mean, doesn't that make a lot of sense, right? Base times height for the volume. If I wanted the surface area of this can, well, I've got two surfaces, right? They're circles. So the surface area would be 2 of these pi r squareds, right? Plus this lateral area. But the lateral area, if I took some scissors and I cut this can right here and I opened it up, wouldn't that just be a rectangle with a height of h? You know, I'm saying if this can had a height of h, and then wouldn't the length of this rectangle here, wouldn't that just be this circle right here, right? The length of the rectangle is just this circle. The perimeter of the circle, also called the circumference of a circle. And so wouldn't that length just be 2 pi r, right? And so if you add the area of the lateral area, the area of that rectangle, that would be 2 pi r h, and that's where the formula comes from. All right, let's do it. We're trying to maximize or minimize, let's see, the least amount of metal. We're trying to minimize the amount of metal. So can you tell me, would that be minimizing volume or minimizing surface area? It's surface area. On your test, I think I asked you to minimize weight. That's also minimizing surface area, okay? So what we're gonna do is we're gonna minimize the surface area. So I'll put minimum here. Whatever you're trying to minimize or maximize, that's what you're gonna take the derivative of. So don't take the derivative of the wrong thing, okay? So I'm gonna take the derivative of this, okay? So that's gonna be, let's see. Oops, I've got r's and h's. I can't even take the derivative. I've got r's and h's. I wanna write h in terms of r or r in terms of h. Come back over here to your constraint equation, okay? This is a constraint equation, but now I've got v's too. Can I replace the v with anything? Yeah, you have to replace it with 355 or else you're gonna be in, you're gonna introduce another variable, which you don't wanna do. Should we solve for h here, or should we solve for r squared or r? Which one's easier to solve here? Yeah, I think h is way easier to solve for. So let's go ahead and solve for h here. Although I did go into a closet and solve for r, and I did turn on the light, and it actually worked too, but it was actually a little bit more work. Okay, so h is a little bit easier. Okay, I'm gonna go over here and I'm gonna replace my h, which 355 over pi r squared. Okay, so this surface area is going to be 2 pi r squared plus, see if this makes sense, 2 times pi r times 355 over pi r squared. The nice thing is, do you see things canceling out here? The pi's are going to cancel out because they're all being multiplied and divided. Anything else? Yeah, one of the r's is going to cancel out. Okay, so I'm going to rewrite this problem. This is 2 pi r squared, and I'm about to take the derivative, okay? 2 times 355, I believe, is 710. And I'm going to rewrite this as r to the minus 1, because I know I'm about to take the derivative, okay? So what have I done? I've set up my formula to maximize or minimize, okay? I've changed all the letters into one variable, okay? Now I'm set to take the derivative. You ready to do it? Okay, the derivative of surface area, we're just going to call it SA prime because we're going to set it equal to 0 anyway. Okay, this is going to be 4 pi r minus 710 r to the negative 2. Do you feel good about that? Okay, so once you do this, you're going to say this is equal to 0. We're trying to find the critical point, right? The critical value. That's going to be where our maximum or minimum is going to be. Okay, how in the world am I going to solve for r here? Yeah, but what the heck is r raised to the minus 2? That doesn't tell me anything. Yeah, if you change this to 4 pi r minus 710 over r squared, okay? And maybe you see it, maybe you don't, but I'm getting kind of excited because what I see is that I could get this into a cross multiplication problem, okay? If I could get one fraction on the left and one fraction on the right, I know it's not a fraction yet, but I can make it into one, okay? And I have an equal sign in the middle, then I can cross multiply. And when I cross multiply, what I get is 4 pi r cubed is equal to 710. So r cubed is equal to 710 over 4 pi. So r is going to be equal to the cube root of 710 over 4 pi. Okay. I'm going to leave this without decimals at first. I'll come back and do decimals with you guys. Okay. If this is what my r is equal to, I'm going to come over here to replace the r here into the h so I can get all of my dimensions. So h is going to be equal to 355 divided by pi, okay, times r squared, which is kind of funky, but it's this cube root of 710 over 4 pi all squared, okay? And you can totally leave your answer like this. I'd be happy with your answer like this. And I'm just writing this to make sure you understand that this is the same as 2/3, right? The power of 2/3 is the same as this cube root. But let me go ahead and put this in the calculator because a lot of students will do this. They'll get it right. Sadly enough, they'll get it right. They don't stop here. I would recommend that you stop here. But if you don't stop here, what they'll do is they'll go to the calculator and they'll get it wrong. And let me show you why you get it wrong. Okay, let's go ahead and go to your calculator. Okay, actually, I'm going to ask you guys to do it because I think when you guys do this, you'll be like, oh, I see now. Okay, go ahead and tell me what your R is. Go ahead and put it in the calculator and tell me what your R is. And I'll bet half of you guys will get a different R from me, possibly because I'm doing it wrong. But go ahead and put this in your calculator and see what your R is. And it might depend on like how much you paid for your calculator too. Sometimes it depends on that. Okay, so I'm going to do a math 4, and I think that's this cube root, which is not what I want. Okay, which is this cube root. Then I'm going to do 710. Okay, now some of you guys are going to just do divide by 4 pi. But I need you to understand, when you say divide by 4 pi here, this is what I think. Your calculator is actually dividing by 4, but actually multiplying by pi. I don't know if you know that, because of PEMDAS. So your calculator is going, oh, you want me to take 710 divided by 4, then you want me to take that answer and multiply it by pi. And so you're going to get the wrong answer, I think, if you do that. You actually have to put the 4 pi in parentheses. Well, let me just see. Maybe you'll get the same answer. I really actually don't know how calculators work, okay? You might get the same answer. Oops, I don't know why this is, I hit that every time. Okay, what if I do 710 divided by, and now I do parentheses 4 pi. Do I get the same answer or not? Okay, so which one's right? It's the second one. Okay, is everybody good with that? So just because you type it in just like you have on your paper, your calculator is not doing the same thing. Okay, why? Because actually we are smarter than our calculators. Okay, that's why. There's a worksheet we can do for fun. It's called, I think it's called all the things your calculator did wrong or something like that. All the things your calculator didn't know. Okay, but we're actually smarter than our calculator. So make sure you put a parentheses there. Okay, so this answer is 3.837. And you can truncate or you can round correctly, but it turns out for this problem, it's the same. All right. Say that again? You totally can. I actually prefer that you do, but I don't know why. Most of you guys prefer to change it to a decimal. That's what I'm saying. So if you do change it to a decimal, you really need to make sure you get that 4 pi in right. Okay, and then over here, guys, if I know what R is, I can just wasn't that the cube root right here? That's what r is right here. I can just square it. So I'm going to square it, then multiply it by pi times second pi. Okay, and then take 355 and divide by that number. Divide it by second answer. Okay, and I'll get 7.674. I hope that's right. Did anybody else do it? No? Okay, thank you. So 7.674, and it turns out the same whether you truncate it or if you round it. Okay, all right, let's do another problem. There's a problem that looks like this. You did it last night too, I think. So did anybody work on it last night? I can use your numbers. Did anybody do this last night? Nobody did it last night? And I think it's number 8. Oh, you don't remember a number? Okay. Well, then I'll just do my problem, I guess, if you guys don't have a number. So let me do my problem. And this is number 8. And this is the one that's going to give you the most trouble, or probably gave you the most trouble last night. Okay, so I actually don't know where it is on here. This one. Okay. So this is a radius of 22. I'm going to work with the radius of 22. If anybody else prefers that I work with another number. Those of you guys online, do you guys prefer another number for this problem, number 8? Nobody here is giving me a number. Someone said 14? Okay, 14. All right, so we're going to go 14 here. All right. The reason that this problem is so hard is because the math isn't real easy on it. So let's go ahead and do this. This is just like your parabola problem, okay? Instead of a parabola, you have a semicircle right here, okay? And you're going to draw a box in here just like you did for your parabola. So I'm drawing a box in here, okay? And the key is, guys, put a point here and call it XY. This is what I recommend, because if you don't do this, it turns out that it's hard to see what the value of X is, okay? So that's my X and that's my Y. All right. The first question says, I want to, a rectangle is constructed with a semicircle, radius 14. And what are the dimensions of the rectangle? Okay, I want to maximize the area of the rectangle. Okay, so let me just write the area of the rectangle. Maximize the area of the rectangle. Okay, you guys agree that this length here is a Y length. This is the Y of my rectangle. Okay, the problem is, guys, this is not the X. The X of my rectangle, do you remember, is only this part. So what is the area of the rectangle? 2xy. Okay, so I'm trying to maximize this, which means I'm going to take the derivative of this, which means I need another formula. So my other formula is going to be the formula for the parabola, but this is not a parabola, so it's going to be the formula for the semicircle. Okay, so you need to know that the formula for a circle, if your origin is right here, the origin is right in the middle of the circle, it's just x squared plus y squared is equal to 14 squared. Like, that's a formula they expect you to know. Right? That's a formula you should know, okay? And so you just solve for y here. So if you solve for y, you'll get y squared is equal to, does anybody know what 14 squared is? Is it 196? Okay, so 196, don't tell my geometry teacher, right? Okay, so minus x squared, okay? And so if you solve for y, do you see that y is actually equal to the square root, and this is what makes it hard, of 196 minus x squared. Is everybody good with that? It's actually plus or minus, but I'm only going to grab the plus because it's the top half of the circle, okay? So this is the key. You need to be able to move to this place right here in order to do this problem. Why? Because you're just going to replace the y right here. So this is going to be the maximum area is equal to 2x times the square root of 196 minus x squared. Okay, yeah. Simplify this? Oh, you can't. You can't. The reason you can't simplify this is, remember, this is 14 minus x, 14 plus x. Okay, it's not the same thing, so you can't pull it out. Okay, good question. A lot of people will think you can simplify it. If it had been 14 minus x times 14 minus x, does that make sense? You can simplify it, but it's not. So it's actually not a square. Okay, not a square, even though it looks like one. Okay, are you guys with me so far? All right, what do I do when I know the formula, okay, and I want to minimize it or maximize it? Take the derivative. So when you take the derivative of this, okay, it's not like the other problems. You actually have to use product rule, okay? And to do product rule, you actually have to rewrite this problem, okay? And the product rule is a little bit messy. Oh, this thing, oh well, it's not a big deal, but it doesn't move down like I like it to. Okay, here it is. Okay, so I'm going to do the product rule here, and I want you to follow me on this because the product rule is not, it's not super easy. You know how to do it, but it's a little bit tricky because we've forgotten chain rule. Okay, so the area is equal to, this is A prime. Okay, the derivative of the first, which is just 2. You guys good with that? Times the second, which is just copy it. So 196 minus x squared raised to the 1/2. Okay, it's product rule, so I'm going to add. What are you going to add? The derivative of the second. So this is chain rule. It's a derivative of this. So remember, it's 1/2 times, carry down the inside, leave the inside alone, take the power down by 1. If I'm at 1/2 on the number line and I take it down by 1, where am I now? Negative 1/2, okay? But remember, leave the inside alone. So this inside was 196 minus x squared. Leave it alone, guys, okay? Then multiply by the derivative of the inside. What's the derivative of 196 minus x squared? Negative 2x. And that is the derivative of the second, which is a little bit more complicated. What do students forget? They forget 2 things. They forget to multiply by this negative 2x, okay? The other thing they forget is to change this power to negative 1/2, all right? Okay, a lot of times I would just forget and just leave out the power totally. All right, but don't forget you need to multiply by the first, okay? So derivative of the first times the second, that was easy, but plus the derivative of the second times the first, you gotta multiply by the first again. And I don't know if you guys see it, but do you see the 2's cancel out? Like one of the 2's is gonna cancel out because I'll get 4 over 2. So I'm gonna cancel out these 2's, all right? So what do I have left? I have 2 times 196 minus x squared raised to the 1/2 minus 2 times x squared. So it's 2x squared times 196 minus x squared raised to the negative 1/2. You guys with me so far? Now this seems really hard, but remember, what do you set a prime equal to? 0, okay? Can you see, I don't know if you guys can see it, but can you see you can end up with a cross multiplying here to solve for your x? You may or may not see it. This negative 1/2 here, okay, it doesn't make any sense when you're trying to solve. So what I would recommend is move it to the bottom. So what I have is 2 times 196 minus x squared raised to the 1/2 minus 2x squared over 196 minus x squared to the 1/2. Now, do you guys see the cross multiplying? Okay, if I can get one fraction on the left, okay, and one fraction on the right, okay, I can turn this into a fraction, and an equal sign in the middle. It has to be one fraction on the left, one fraction on the right, and equal sign in the middle. I can actually cross multiply. Look what happens when I cross multiply. Actually, I don't know if you guys are okay with this. Are you guys okay if I divide by 2 on both sides? Okay, because I just want to get this a little bit simpler. This would be x squared is equal to, what's 196 minus x squared 1/2 times 196 minus x squared 1/2? When the bases are the same, what do you do to the exponents? It does cancel out, but you add the exponents, right? So 1/2 plus 1/2 is actually 1. So yeah, in a sense, it ends up canceling out. So this is 196 minus x squared raised to the 1 power, which is just 196 minus x squared. Another way to think about this is really, let me rewrite this, see if this makes sense. This is the same thing as the square root of 196 minus x squared, right? And this is the same thing as the square root of 196 minus x squared. Well, what's the square root of that times the square root of that? It's 196 minus x squared, okay? All right, I'm pretty much done. I'm gonna add x squared to both sides. I'm gonna divide by 2. I don't know what this divide by 2 is. 98, thank you. Okay, and then, so x is gonna be equal to plus or minus the square root of 98. Okay, if I did that right. Is that really 98? Oh, I just saw something else, but that's fine. Okay, plus or minus square root of 98. That's nice, actually. because we got a fraction in other class. Okay, so what I know, this x here is actually the square root of 98. This x here is actually negative square root of 98. Okay, what's my y value? How do I find my y value? My y value is over here. It's equal to, no, it's not over here. It's my y value is right here. My y value is here. My y is equal to the square root of 196 minus x squared. Didn't I have x squared down here somewhere? X squared is equal to 98, right? Okay, so I'm going to put in 98 right there. Okay, what's 196 minus 98? Is it 98? Oh, okay, so this is actually the square root of 98. So this y value is the square root of 98. Okay, so let me make sure I answered the question. I have all my x and y values. The rectangle with the maximum area has a length of what and a width of what? Okay, so they don't really tell me which one's the length and width, so I'm just going to guess. But I'm going to call, I guess, the height the width. So this is square root of 98. And guys, what's the length going to be? What's this length? It's 2 times the square root of 98. Do you guys see that? It's 2 of those, okay? And you can ignore the negative because it's all length and width, so it's all just dimensions. And that is the answer. It says use radicals, so you'll leave it like that. Okay, any questions on the semicircle? I actually think the semicircle is the hardest problem you have. Okay, yes. Not this one, because the way it said type exact answers, it won't accept decimals. Okay, but if it said, I don't know, it'll say something else if it wants decimals. Yeah, this one's not going to take decimals. Okay, what other questions do you guys have from your homework 1 through 8? Yes. Can you do one of the problems where it gives you the area and wants you to work backwards? Like, do you know which problem that is? Number 4. Okay, yeah, let's do number 4. Does it look like this? Yes. Okay, so let's do it. What number did you have? I had an area of 4. Oh, just 4? Okay. That's teeny tiny. Okay, let's do it. All right, define the smallest perimeter and the dimensions for a rectangle with an area. All right, what are we trying to maximize or minimize here? Perimeter. What's the formula for perimeter? Is this a rectangle? Yeah. Okay, so if I call, what letters did you use, Emily? I mean, for x and y. So I'll do y here and x here. Okay. So perimeter formula, if this makes sense, is 2x plus 2y, right? And what you want to do is minimize this. So you have to take the derivative of this. You can't choose what you take the derivative of, okay? Chris, can you see with your eyes closed? So guys, we need to take the derivative of perimeter, okay? So what you want to do is get a formula that you can get rid of the x or y. You need another formula. Do I have an area formula here? Yeah, right here. So I have area is equal to 4. Okay, but the formula for area is xy. Do you agree? So what I have, my other equation is xy is equal to 4. This is my constraint equation. Solve for x or y. It doesn't matter what you solve for. Emily, what did you solve for? Oh, okay. Well, let's solve for y. So y is equal to 4 over x, right? So I'm going to come over here. Wherever there's a y, I'm going to put in 4 over x. So what I'll get is the perimeter formula is 2x plus, this is really 2 over 1, right? So it's 8 over x, okay? Oh, and that's my formula for perimeter. Okay, once you get the formula, what do? Take the derivative, okay? So let me rewrite this, guys, so it's easier to take the derivative, okay? So p prime is going to be 2 minus 8x minus 2. Take the derivative and then set it equal to 0. So this will be 0. Okay, guys, a lot of these, the cross multiplying will work. Okay, how do I solve for x minus 2? I don't know how to solve for x minus 2, but I certainly know that I can rewrite it as 8 over x squared. Okay, and if you rewrite this, what you get is you can get 1 fraction on the left, 1 fraction on the right. At least I can make it a fraction, and an equal sign in the middle. And then what you do is you can just cross multiply. 2x squared is equal to 8, x squared is equal to 4, so x equals plus or minus 2. Okay, but let's be logical about this. What did I define as x and y? I think it was just the dimensions, right? So x really can only be positive 2 because this is a geometry problem. Okay, did I tell you a long time ago when they were developing geometry and they're trying to look at the planets and the stars, you know, those big guys like Aristotle and Copernicus and all those big guys, that they had a fight if there was such a thing as negatives or not. Did I tell you this? Like they had a fight, and it was kind of like the Democrats and the Republicans. And they're like, you know, the guys doing all these, you know, these planetary things, they're like, there's no such thing as negative. There can't be, okay? Because when you calculate things, there's no such thing as negative. And then there's another side that was like, oh yeah, negatives exist. And so they actually killed each other, okay, over like, you know, is there such thing as negatives or not? Okay, kind of like the Democrats and Republicans. Okay, so, all right, so our answer for X is 2. What are the questions? The questions is what are the dimensions, okay? So I know one is, if I know that X is 2, then what's Y equal to? Also 2. So I think I left out some blanks or something, but 2 by 2. Another question they could ask you is what is the perimeter, right? So you know this is 2 and you know this is 2. So my perimeter here is 8. You can check my math on that. They could also ask you the area. Oh no, they gave you the area. They won't ask you the area. Okay. Everybody good with this question? This is a good question. All right. Any other questions? Yeah, Alexis. Okay, is that the next one? Oh yeah, this is a good one. Okay. Yes, I can use your numbers. Okay, so this is 100, 100, 100. I think if I set this up for you, you're good to go. What they want you to do is they're saying you've got a whole bunch of these little rectangles, and you need to make sure every little one of these areas is 100. What I do is call this Y, call this Y, call this Y, call this Y. I didn't really mean to repeat that 5 times, but you need to, like, all those are Ys because they're the same, and these are all X's. Does that make sense? And they're saying, what are the dimensions of 10? You want to minimize the amount of fence. Well, the amount of fence, so I'll just call that F, okay? You want to minimize that. So the formula for F is going to be add all of them together. Does that make sense? Let me write minimize. We're trying to minimize that. So you want to take the derivative of this. But to take the derivative of this, you want to get rid of either the Y or the X's. So go find another equation. Go find your constraint. And it tells you the area. Oh, this is 100, right? The area of each one of these is 100. So what's that formula? Right? Y times X equals 100. X times Y equals 100. So solve for one or the other. I like to solve for, if it's easy, I like to solve for Y, because then when you replace Y here, you get all X's. And I like to work with X's. But it doesn't really matter. If it doesn't matter to you, you'll just end up working with the Y's. So this will be 5 times 100 over X plus 4X. So it would be 500. Oh yeah, it is 500. 500 over X plus 4X is equal to F. And then take the derivative of that, set it equal to 0, and it'll be good. Oh. Okay, so you need to go more than this. Okay, we'll do it. Yeah, let's do it. Okay, well, I don't know yet. Hold on. Let me work it as fast as I can. Here, I'll race you. Okay, wait, you took the derivative here, right? So it's negative 500x minus 2 plus 4. Did you do that? And you set this equal to 0, right? You take the derivative, set it equal to 0. I'm going to do cross multiplying. So this is what I get. So I get x squared is equal to 500 divided by 4. I'm pretending like I know what I'm doing. Is it 120? I actually don't know what I'm doing. 500 divided by 4. What is it, 125? Okay, thank you. 125 is actually 25 times 5. Is that right? Right, so that's actually 5 square root of 5. Is that right? 25 times 5, 5 to 10. Yeah, it's 25 times 5. So that's 5 root 5. Okay, over here, did you solve for X or did you solve for Y? Okay, over here though, you got 5 times, okay, your x's and y's are switched with mine. Okay, why don't I just switch everything? So this is x, 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 x. Okay. Okay, I'm going to try to make mine like yours. So you actually got 5x plus 4y, right? And then you multiplied 5 times, did you multiply 5 times 100 over y plus 4? Y? Okay, okay, what if we solve for y here, and then you'll get 5x plus 400 over x. Yeah, is that what you got? Okay, good. Right, like that, right? Okay, then you set this, did I take the derivative yet? I did. Okay, so you set this equal to 0, so x squared is equal to, well, I can't do that fast. 400x squared is equal to 5. So then you get x squared is equal to 400 over 5, is that right? Okay, so then you take the square root of both sides. So was that, is this 80? Okay. Square root of 80, which is 4 root 12. So that's 16 times 12. Is 16 times 12 80? 4 root 12? Oh, 4 root 5, sorry. Okay, so that'd be 16 times 5. Okay, so 16 times 5 is 80. Yeah, that's right. So 4 root 5. All right, I agree with that. I don't know how, I don't know what we did before. Did I do something wrong before? Okay. Okay, so they're asking for the y sides, right? So y is equal to 100 divided by 4 root 5. Is that right? 100 divided by 4 root 5. And then if you put that in, it doesn't work. No, that's it. That's my answer. Oh, change it to 25 over root 5? 20, no. Oh, yeah, that would be 5 root 5. Yeah, you're right. Did you get 5 root? Oh, okay, yeah, it should be 5 root 5 and 4 root 5.